Hello students, welcome to today's GATE video session. Myself S.Bharathi, Associate Professor, EEE Department from SAEC Engineering College. This is the GATE syllabus for our electric circuits, and I have already shared 2 videos regarding our electric circuits. This is our next video. Today we are going to talk about some problems based on GATE problems based on electric circuits and Thevenin's theorem. First we will see about the basic problem, some important 2-mark problem. So here in this problem it is given that the number of junctions in the circuit is, so some options are given, some circuit is given. We have to go for finding how many number of junctions or how many number of nodes in this particular problem. So here options are 6, 7, 8 and 9, like that it is given. So this is the given circuit for us. And we have to find how many number of nodes. Students, first we should understand what about the nodes. Nodes are nothing but where more than 3 branches are meeting at a point. So it is a junction point where more than 3 branches are meeting. For example, we can say in this problem, this will be the So in this problem we can say here only 2 branches are meeting here. So we cannot consider this as the principal node. And if you see this point A, here 3 branches are meeting from this one. So this will be one branch, this is the another branch, and here this will be the another branch. So like that 3 branches are meeting at this point A. So we can consider this will be the node. And if you talk about this point B, here also we can see 3 branches are meeting. Here this one, this one, this one, like that. At point B also, here 3 branches are meeting. And similarly here C, 3 branches are meeting. Not only 3, more than 3 branches are meeting means we can say it is a node, principal node. And here B, again this will be the branch. Here so many branches are meeting, so that will be the node. And here also we can see this point, again from this one. So here it is meeting, so this will be the node. Similarly E, F. So like that students, we can say how many number of nodes in this branch is nothing but 1, 2, 3, 4, 5, 6, 7. So students, in this problem, the number of principal node is nothing but 7. So here we can say the option B will be our answer. So this option B will be our answer. So problem is given, some circuit is given for us. We have to find how many number of nodes in this particular problem. So we have calculated in this problem, the number of nodes is nothing but 7. Okay, shall we move on to next problem now? It is a very simple problem only. Okay, but anyhow, we should know how many number of nodes present in this and how to analyze the node and how it is different from when 2 branches are meeting, we cannot consider that is a node. So there should be more than 3 branches meeting at a particular junction or point is nothing but a node. Like that we have to consider. So I think we can move on to next problem. So students, it is our next problem. We have to find what is the power delivered by this 10-volt source. So here, this is the 10-volt source. So in this problem, we have to find what is the power delivered by the source. This is also the problem which is coming under our normal Kirchhoff circuits only, normal our circuits only. So here we can say, we can go for analyzing this problem by any method. We can go for nodal analysis method, or we can go for normal problem solving method, any method, but we have to find what is the voltage, what is the power delivered by our 10-volt source. So the options are given 0, 100, 50, dependent on the value of alpha. So like that it is given. So see this problem students, here some twist is given. So here the resistance value is not directly given, it is mentioned as alpha. So by normal problem solving we cannot proceed, by normal mesh analysis or nodal analysis, by normal mesh analysis we cannot proceed. So we have to go for some other method, right? So based on this problem, we have to go for analyzing this problem now. So this is the circuit given for us, 10 volt power delivered by your power delivered by the 10 volt source we have to calculate. power delivered by our 10 volt source we have to calculate. So in this problem we have to calculate the power delivered by the 10 volt source. Now we have taken the circuit. We have to go for analyzing this problem by normal nodal analysis method. So here we can assume that the node voltage at this point is VA. By the normal nodal, using nodal analysis, we can go for writing the node equation for our VA. So at node VA we can go for writing. So at node VA we can go for writing what is the nodal voltage. So here we have to consider that VA as the greater voltage. So VA minus this 10 volt. VA minus this 10 volt divided by the resistance alpha. That will give you the current passing through that particular branch. Through that particular branch to the VA, node VA. So here we can say VA minus this nodal voltage minus this voltage, VA minus 10 divided by alpha. So VA minus 10 divided by alpha, that will be the current passing through VA. Then here we have the current passing through this element. So VA by 1. Here the resistance is 1, the voltage is nothing but VA. So VA divided by 1. Here it is nothing but only the current source. That current source is passing towards the node, so that will be equal to 10. So this will be the current source value, which is directly taken as 10. So this is the nodal equation for that particular node VA. So again I am repeating, VA minus 10 divided by alpha and VA by 1, which is equal to 10. Now we can go for solve this equation. We can go for taking an LCM. So VA minus 10 plus VA divided by alpha. So if you are taking LCM, this alpha will be multiplied. So VA into alpha, which will be equal to 10. Now we can go for passing this alpha. So VA minus 10 plus alpha VA, which will be equal to 10 alpha. Like that we can go for writing it. Now we are collecting alpha in one terms. So here if you are taking VA outside, here we have VA, here we have VA. If you are taking VA outside, this will become 1 plus alpha VA, which is equal to, here we have 10 alpha, here we have minus 10. When this minus goes here, it will become plus 10. So 10A, 10 alpha plus 10. So like that we can write 1 plus alpha VA. If you are taking this 10 outside, alpha plus 1 into 10, like that it will come. So here on both the sides we have 1 plus alpha, 1 plus alpha. We can go for cancelling it. So we can get VA as our 10 volts. Now we can say the voltage at that particular node VA is equal to 10 volts now. Now what is the current I? This is the current I. So I is given by that 10, this 10 minus VA by alpha. That is the current passing through that particular branch. So this branch, right? So this is the I which is passing through that particular branch. So I is equal to 10 minus VA by alpha, which is equal to. So already we have calculated VA is equal to 10. Now the current passing through the particular branch is 10 minus VA by alpha. So what is VA now? 10 minus 10 divided by alpha. So it will become 0. So what is the current? 0. That's all. So the current delivered by the battery is nothing but 0. That is, the current passing through this branch is 0. The current will be delivered by our 10 volt battery source, that will be 0. Now what will be the power delivered by the 10 volt source? Power is given by the formula V into I. So power is equal to V into I. We can write what is voltage for the particular voltage source. It is 10. And what is the current I? What we have calculated here, the current value becomes 0, right? Now the current is becoming 0. That's all, students. Power is 0 now. Current is 0 means power value will become 0. So we can understand from this explanation, power delivered by the voltage source will be 0, right? So here we have some choices. Let us verify the choice now. So for this problem it is given, what is the power delivered by the 10 volt source? So now the option A is correct. Yes, for this problem the option A, nothing but the power delivered by the source is equal to 0. That is, the power delivered by the 10 volt source, power delivered by the 10 volt source will be equal to 0. That is the answer. Okay, any doubt? So if you have students like that, we can go for explaining how we are getting the power delivered by the source as 0. Shall we go for next problem now? So next problem, before starting with our next problem, I will just give the brief introduction about our Thevenin's theorem, because next problem will be based on Thevenin's theorem. Thevenin's theorem states that any linear, complex, bilateral network can be converted into a very simple network which consists of the voltage source in series with the Thevenin's resistance. The voltage source is nothing but the Thevenin's voltage source, and resistance is nothing but the open circuited terminal resistance, looking back resistance, which is nothing but the Thevenin's resistance. So like that we can go for explaining our Thevenin's theorem. So here we have so many elements, for example R1, R2, R3, R4, R5, any complex, any linear network which may consist of any resistive element, inductive, capacitive, anything. It may be the AC circuit also, no issues, right? So if we have the complex network, linear network like this complex network which consists of so many elements and so many voltage sources, current sources like that, that can be converted into a simple network which consists of the voltage source VTH and Thevenin's resistance RTH. This VTH is nothing but the voltage drop across the open circuited terminal across which our load resistance is present. Okay, here load resistance is not there, the terminals are mentioned as AB. So the voltage drop across the open circuited terminals VTH is nothing but our Thevenin's voltage, and we have to calculate what is the looking back resistance. Towards the open circuited terminal we have to calculate what is the resistance present in the circuit. In case of DC circuit we can say it is the resistance, Thevenin's resistance. In case of AC circuit, if we have inductive, capacitive elements, we can say it may be the Thevenin's impedance. At that time it will be, this RTH will be replaced by ZTH for AC. Okay, as it is your DC, I have mentioned all the values as R2, R1, R3 like that. Only resistance I have mentioned. So we can go for replacing it by what? RTH. So that will be the looking back resistance. In this way we have to calculate. When we are calculating RTH, if we have the current source, it should be open circuited. Okay, when we are calculating RTH, if the current source is present in that circuit, that should be open circuited. So current source must be open circuited, and if we have the voltage source in the circuit, see this is the voltage source, if there is a voltage source, it should be short circuited like this. Okay, so there should not be any circuit, any source must be there in your circuit when we are calculating RTH. Yes, so like that we can go for replacing the complex network into a very simple network which consists of VTH and RTH in series. And this terminals A and B are the same. If there is any RL present in this AB, across AB, that RL may be connected here to find the current passing through RL. So the IL value will be given by this voltage source VTH divided by sum of these two resistances RTH and RL. So IL value will be given by VTH by RTH plus RL. So this will be the explanation or the brief explanation for your Thevenin's theorem. So based on this knowledge we can go for the next problem. So students, this is the problem given for us. So here some, if you see the circuit, you can understand it is not a independent voltage source and current source. Here we have the dependent source. Okay, dependent source is present. Pi is the value for that voltage source, which is the dependent voltage source. So here for the circuit we have to find what is the Thevenin's voltage and Thevenin's resistance. That is what they are asking in the problem. For the network shown, the equivalent Thevenin's voltage and Thevenin's impedance as seen across terminals AB is. So we have to find what is the voltage drop across AB. That will be our VTH. and we have to find out what is the looking back resistance, that will be our RTH. So in this problem we have to calculate what is VTH and what is RTH. That is our problem. Some options are given: 10 volt in series with 12, 50 volt in series with 2, 65 volt in series with 15, and 35 volts in series with 2 ohms. Like that some options are given. Students, let us solve the problem and find out what will be the correct answer. So first step is calculating VTH. As we already said, the voltage drop across the open circuited terminal are the terminals A and B is nothing but the VTH. So here we can say this will be our A and B, which is the open circuited terminal. It is your VTH. So what is the voltage drop across that particular terminal A and B that we have to calculate? That will be our Thevenin's voltage now. So how we can go for calculating it? VTH, right? So now it is the open circuited terminal. This terminal is considered as open circuited. Students, we know that very well. In open circuited terminal, no current will flow. So we can consider there is no flow of current in this particular branch. So here we can say the current passing through that particular branch will be 0, right? And here what is the current flowing through this branch? This will be our 5 amps. So this 5 amps will be passing through this one. As there is no current in this branch, current is 0, only this 5 amp will be passing through this particular branch. Yes? So what is the current passing through this 10 ohm resistor now? And what is the value of 5? I will be given by 5 amperes only. Okay? Because this is the 5 ampere current source that will deliver 5 ampere current source. And as it is open circuited, there is no current in that particular branch. So the current passing through this will be 0. Here it is 5. So what is the current passing through this 10 ohms? Nothing but that I value will be equal to 5 amperes. So we can consider I is 5 amperes. Let it be. Our I is 5 amperes. Now we have to go for calculating VTH, right? What is the voltage drop across our VTH? VTH is given by, here there is no current, therefore this resistance will become ineffective. As there is no current passing through the 2 ohm, which is 0, right? So the resistance can be neglected. That will become ineffective now. Now we can consider here we have a voltage source, which is a dependent source. The value is given as 3I. Now the terminals are nothing but here it is minus, here it is plus. So what is the voltage source value now? 3I. Now the current passing through this 10 ampere will be, current passing through this 10 ohms will be, it is 5 amperes. It is our I value. Current passing through this 10 ohm is nothing but I. Now we can say the current voltage drop across this 10 ohm is nothing but 10 into I, which is the voltage drop across the 10 ohms, which is 10I. Now we can understand, we should conclude what sign we have to represent, whether it will be given by plus sign or minus sign. Now here it is minus, and then the current is passing through this one, the centering end will be positive, leaving end will be negative. So minus is connected to positive, so there will be positive sign for your voltage drop across this 10 ohm, so it will be 10I. We can say VTH is equal to 3I plus 10I, which is 13I. Now already we have calculated our I is nothing but 5 amperes. So 13 into 5 will be given as 65 volts. So students, VTH for this particular circuit is nothing but 65 volts. VTH nothing but Thevenin's voltage for this particular circuit is 65 volts. Okay. Now we have to go for calculating what is RTH, Thevenin's resistance. For calculating Thevenin's resistance, already I said we should go for removing the that is, we have to go for removing the current source. If there is a current source, that should be open circuited. Already there was a current source. Here that was open circuited, and if there is any voltage source, that should be short circuited. So here there is no voltage source. Instead of here we have a dependent voltage source that we cannot remove. So it will be there as it is. As it is open circuited, there is no current passing through that particular branch. Right? Now we have to conclude the current delivered from this side, that will be IDC. let us, we are assuming that it is IDC, that IDC is passing through 2 ohms, and this IDC, here we have the drop, and again we have the drop here. So we can go for concluding, as there is no current here, this current I value will be equal to this IDC itself. So I is equal to IDC. IDC is nothing but the current delivered from our terminal AB. Like that we are assuming IDC. So as there is no current in this branch, because current source is open circuited, as there is no current in that particular branch, IDC will be equal to I. Let us have this statement, let it be expression I is equal to IDC. Now we can go for writing what is VDC, voltage drop across that particular element. So VDC is given by, here the current passing through 2 ohm is 2 ohm is IDC. So the voltage drop across the 2 ohm is nothing but 2 into IDC. And the voltage drop across this 3I dependent source is nothing but 3 into I. And the voltage drop across this 10 ohm is nothing but 10 into I. Here IDC is entering end will be positive, leaving end will be negative. Here already there is a sign for our 3I dependent source. And again when it is entering, this end will be positive, this end will be negative. So here opposite terminals are connected means we can go for adding the voltages, right? So according to that, VDC is equal to 2 IDC 3I plus 10I. Already we know that I is equal to IDC. So VDC is equal to 2 IDC, 3 IDC, 10 IDC. So if you add all those things, VDC equal to 15 IDC. 13, 3 plus 10, 30 plus 2. So 15 IDC will be the value VDC. We can go for getting a fraction. VDC by IDC is equal to 15. We know that voltage by current is nothing but a resistance value. That is what our RTH now. So RTH is equal to 15 volts. RTH is equal to 15 ohms. So already we have calculated VTH and now we have calculated RTH. Let us see what about the problem and what about the option given. So here VTH we have calculated is nothing but 65 and RTH we have calculated is nothing but 15 ohms. So we can go for checking it with the options. Here if you see 16 volt in series with 15 ohms. So 16 volt will be the Thevenin's voltage. 16 volt will be the Thevenin's voltage VTH and 15 ohms will be the Thevenin's resistance which is RTH. Right? So here in this problem the option B will be the correct answer. So like that we can conclude this problem. So students, I hope this will be enjoyable and you can understand all the concept. Let us see in our next video. So thank you students, we will continue in our next video.